All right, Brian, what's the function? This is what, number 63?
Yeah. Negative 2x squared over x squared minus 9.
Right, exactly. Okay, Jack. All right, thank you. And we'll call it f of x. All right, what's the denominator? Tim, factor into.
X plus 3 and x minus 3.
X plus 3 and x minus 3. So what are my vertical asymptotes? 3 and negative 3. All right, good. X equals 3, x equals negative 3. All right, so I'm going to draw those in there now. So 3, got that one. Negative 3. Close out. All right, horizontal asymptote. To me, one missed the most. Nathan, you know what it is, or what do you think it is?
I put none.
None. Oh,
Is it 0?
no. Over 2. You want to go for the strikeout?
No.
Okay, all right, fast. Brooklyn?
I put 0.
You put 0. Okay, now, and then I know we didn't maybe cover it. We kind of did it in between yesterday and today. What are we looking at for horizontal asymptote? Colton, what are we looking at?
I put negative 2 for it.
What are we looking at? I'm looking for something in particular.
Like the first two leading coefficients before the variable, like they're the same degree.
Degree of the numerator versus degree of the denominator. Okay, now you were right. It is y equals negative 2. If the degree of the numerator is the same as the degree of the denominator, if that is the case, then you look at the leading coefficients, like Colton said. What is the leading coefficient in the top one? It would be negative 2. This would be a 1. It would be negative 2 over 1. When is it 0? When is it 0? Luke?
When the denominator has a larger degree.
When the denominator has a larger degree, that is correct. So if it was negative 2x over x squared minus 9, like that, smaller degree here, larger degree here, no horizontal asymptote 0. So we got a horizontal asymptote. It is negative 2. Okay, it is negative 2. So we got that drawn. Or we'll draw that. All right, x-intercepts and y-intercepts. What about those? Josh, you got anything for x-intercepts and y-intercepts?
I got 0, 0.
Good. Where does the numerator equal 0? And this happened yesterday in a problem. It'll happen in several others, not always. But so the numerator is 0. The only thing will make that is 0. And then that'll happen to give us the same thing here. So I graph that point here. Now it's just, the big thing is picking points to plug in. You got to test them. Because like I said, these rational functions, they have crazy shapes. So you can't necessarily assume every time. So between and beyond, x-intercepts and vertical asymptotes. So this is the furthest one on the left, so I need a point to the left of negative 3. I'm going to plug in negative 5. I need a point in between 0 and negative 3. It doesn't matter, negative 1 or negative 2. I just pick negative 2. A point here, which is 2, and then a 5. So negative 5, negative 2, 2, and 5. I'd have to see those minimum. You couldn't give me less. All right, did anybody happen to plot those points? Those the same ones? All right, Colt, what do you got for negative 5?
For negative 5, I got negative 3.125.
Negative 3.125. Okay, how about negative 2?
1.6.
1.6. How about 2?
1.6.
How about 5?
Negative 3.125.
Now, I really emphasize you got to watch whether it's positive or negative, because if you get the wrong sign or if you get the wrong value, it's just, the whole thing is going to be jacked up. So you really got to be careful of that. So, all right, we got those. Negative 5. 1, 2, 3, 4, 5. Negative 3. So we're down here somewhere. Negative 2, 1.6 here. 2, 1.6. 5, 1, 2, 3, 4, 5. Negative 3. All right, from that we got enough. Now, as I said, if you're really unsure, plot more points. Pick another point. See what's going on. You got to know what's happening around the vertical asymptotes. You got to know what's happening around the horizontal asymptotes. in the middle, anything can happen, but to the left and to the right, it has to be going towards that -2 value. And so this is the only thing it can do. It cannot at any point like reroute itself and go up and hit the x-axis. The only time it hits the x-axis is right there. And via vertical asymptote, it either needs to be going up or down. Okay, so same thing over here. It's got to look like this. Now, this might be confusing because I'm sure a few of you are like, well, that point should be down here or this point should be down. It doesn't have to be. All right, so I got this point, and if you wanted to double check, you could plug in a couple more points. So that would look like that. I know you probably didn't list the domain, but let's list it here now. Because I don't think it specifically asked for it. All right, domain. Carlos, what do you think? Everything but what?
I put -infinity to -3, union -3 to 3, union 3 to infinity.
Okay. You're on a roll. How about the range?
I put -infinity to -2, union 0 to infinity.
Okay, it does not include -2. Union 0 does it include 0? Yeah, because it hits a point 0, 0. So I got a bracket there, 0 to infinity. So we got a gap there. So you got a gap from -2 to 0. So like I said, these are all very different. Okay, you can't assume one thing versus the other. Okay, so hopefully that's what you got. Like he said, it just takes a little bit of time as you go through these. All right, so that was 63. I want to make sure we at least go through that. All right, let's go back to your guided notes. We're going to finish those. This is kind of the last thing of the chapter. And then we're going to hit some reviewing tomorrow, review Monday, test Tuesday, Wednesday. Okay. There's a lot in this chapter. You have to think back to all the things we've done with your graphing and everything. All right, so the third one here is similar, a little bit similar to what we just did. A little bit similar. Go ahead and, well, the denominator doesn't factor. Right, it's x minus 2 times x minus 2, but it doesn't necessarily factor. Vertical asymptote. Luke Hirschberger, what do you think?
Would be 2.
2. Is there anything else? Is there another one? Madison, is there another one? I don't think so either. Just x equals 2. See, I tried to trick you. That wasn't nice of me. X equals 2. All right, so draw that in. All right, now everybody think about the horizontal asymptote because that tends to be the tougher one. So think about what it will be. Vertical x equals 2. Horizontal, Sam. What do you think?
Y equals 2.
Y equals 2. They're same degree. Same degree. So you look at the leading coefficients. You know, you can FOIL that out. You don't need to. You should be able to do that mentally. So y equals 2. And I got a dotted line. Root 2. All right, so the last one, the 163, you had 2 vertical asymptotes when it was x squared. This time we only got 1. Okay, and that's fine. X-intercepts. All right. What do you think on that one? Maggie, X-intercepts.
0.
0. Well, you let the numerator equal 0. So let numerator equal 0. And that's just 2x squared equals 0. Well, that's just going to give me 0, 0. And the y-intercept, now these happen to be the same, but you're plugging in 0. Well, when I plug in 0, I'm going to get the same thing. So I get 0, 0. So I got the point 0, 0. That's it right now. That's all I got. All right, now I got to plug in some values. All right, between and beyond, I only got one vertical asymptote. I only got one x-intercept. So when I'm doing my little chart, I'm going to plug in -2. I got to plug in something between 0 and 2. So I'm going to plug in 1 and I'm going to plug in 4 just to see what happens. All right, you do that. double check, triple check your signs. Make sure you're, whoever you're sitting by, you guys agree on. Maybe figure out which one we're on here. We are doing this one right there. Okay. This is yesterday. This is the little procedure we go. Okay, and it goes through 1 through 4. Basically, these 4, not in order though. These are all interchangeable. Doesn't matter which one you do first. And then we're right here on number 5. Plot and use one thing to plug in and see what we get. So that's where we're at. Right, negative 2. Let's see if I can do this. I'll probably mess it up though. All right, negative 2 squared is 4. 2 times 4 is 8. 8 is in the numerator. Negative 2, negative 4. Is it 8 over 16? Positive 1/2.
Yeah.
So we got positive 1/2. 1. Let me plug in 1. That gives me 2 on top. 1 minus 2 is negative 1. Negative 1 squared is 1. So it's just 2, right? So 2. 4. Oh boy. 4 squared is 16. 2 times 16 is 32. 32 over 4 is it 8? Plug in 4, I get 8. That's supposed to be it. All right, let's do something real quick here. 4, 8, 1, 2, 3, 4. That's way up here, which is fine. I'm gonna plug in 1, 2, 3, 4, 5, 6, 7. Plug in 8 real quick. I just want to see where that's at. All right. Give me a little bit better idea. So if I plug in 8, I don't know how easy this will be. 8 squared, 64. I get 128 over 8 minus 2 is 6. 36. Anybody help me out? 128 divided by 36. And 3.55. All right, so give me a decimal. 3.55. All right, let's graph those points. Negative 2, 1/2 is right here. 1, 2. All right, we have talked repeatedly, and we'll keep talking. It can hit the horizontal asymptote. What does it do right there? It hits the horizontal asymptote. Okay, that is fine. All right, 4, 8 will be up here. 1, 2, 3, 4. 8, and then 8, what is it? 3.55. 1, 2, 3, 4, 5, 6, 7, 8. 3. All right, go ahead. I want you to think what it looks like. Get your little picture in your mind, and then go ahead and graph it on your calculator. Okay, and see if what was in your mind matches up what your calculator tells you. So let's use your calculator as a little bit of a resource here. Because there's a lot going on. So I want you try to figure that out and then kind of verify whether you're right or wrong using your calculator. That's what you have, right?
Mm-hmm.
Good. That what you got?
Yeah, no.
No, we put that way. All right, so what do we got here? We got, I'm gonna grab it, 2x squared, y equals 2x squared, 2x squared divided by x minus 2y squared. Graph. Okay, so you get this, look here. Here's what's going on. Around a vertical asymptote, it either has to go to positive infinity or negative infinity. To the left, it cannot, okay? Here's what you got to watch, which I think I see a lot. It cannot, like, do this. It cannot do that. All right, because it has to go where? It has to go to that line. So that's why it flattens out on this case. So really, it's going to eventually go to 2. Now, it just comes here and it bounces, and it goes up. Looks like this. Now, over here on this side, okay, those will eventually go to positive infinity. That'll flatten out and go to 2. So it looks like that. I told you, rational functions, crazy. They're never going to be the same. So you just got to be careful. You really got to think through this. And here's what I would do. I would say, all right, I'm not really sure what's going on. I'd plug in -10 or something further down the line to give me an idea where it's heading. But that's the case. All right, domain, everything but 2, right? Everything but 2, negative. Negative infinity to 2, union, 2 to infinity. Range. All right, as you look at that one, range, Ty Miller, what do you think?
0 to.
Does it include 0? Yes, it includes 0. 0 to infinity. Okay, that would be correct. All right, so there we go. 0 to infinity. All right, so like I said, you never know what it's going to look like. All right, flip it over on the back. Now, this is really good. Now we haven't dealt with this. The degree of the numerator is higher than the degree of the denominator. You don't get a horizontal asymptote. You get what's called an oblique asymptote. Oblique or slant is going to be diagonal. All right? So we're going to figure this out. Vertical asymptote is going to be the same. Go ahead and factor the numerator. Go ahead and factor the numerator. And that factors into x plus 4 times x minus 2 over x plus 1. Vertical asymptote is at -1. X equals -1. Let's do x-intercepts and y-intercepts, then we'll come back to oblique asymptote. All right, you think about x-intercepts, you think about y-intercepts. This because they're not 0, 0 in this case. So see what you come up with. And I'm just drawing in my -1 there. All right, Alex, you know what the x-intercepts are?
-8, 0.
X-intercept? I'm going to say no. It's not -8, 0. Where you getting that because of this -8?
Yes.
Okay. That's your y-intercept. Okay, your y-intercept is where you calculate f of 0. You plug in 0, see what you get. So if I plug in 0, it doesn't matter which function you plug it or which form you plug it into. That'll be -8 over 1, which is -8. So that would be 0, -8, y-intercept. Okay. All right, how about x-intercepts? Okay, Ryan Hammer, remember?
Yeah, -4, 0, and 2, 0.
So your numerator equals 0. Okay, so these two cases here, that's why you want to factor it. So you would set both of those equal to 0, and it would be -4, 0, and it would be 2, 0. Okay. Now, I'm going to plot those points, -4, 1, and 2, 0. Now, all right, oblique asymptote. Oblique asymptote. Here's how you find this. You got to use long division. Take your function. You got a little bit of room there below before the next one. You got a little bit of room there. We're going to do long division. So you're going to take x plus 1 divided into x squared plus 2x minus 8. Okay, you got to go, and we got to go through those steps. Okay, typical like we do. So what times x gives me x squared? Okay, it'll be x. X times x plus 1 gives me x squared plus x. Subtract. Subtract. That gives me 2x minus x, which is x, minus 8. What times x gives you x? 1. Plus 1. 1 times x is x. 1 times 1 is 1. Subtract. What do we get? -9. Okay, you can't go any further. So here's what you got. Let me write this out. You got x squared plus 2x minus 8 divided by x plus 1 equals x plus 1. Hold on here a second. X plus 1 plus -9 over x plus 1. All right, here's the deal. This answer right here, that is your oblique asymptote. It is coincidence that it is the same as what we divided by. So don't assume that whatever we divide by will come out and be that answer. That's not always the case. What happens when you plug in really large numbers? This basically becomes x plus 1. Now, is it going to be a line? So you got to write it as y equals x plus 1. That is our oblique asymptote. We got to graph that. Well, what's its slope? What's its y-intercept? So y-intercept is 1. Slope is 1. So 1 over 1. So I'm going to put a dot at 1. And I got a little bit of an advantage because I got my little dotted line tool. And I'm going to extend this one over here. Okay, as it goes towards positive infinity and negative infinity, it has to go towards that line. Okay. Now we got to pick some points. We got to do a little bit of a table to see what's going on. So let's pick, again, same thing, between and beyond. -4, I'm going to pick -6. I need something in between -4 and -1. It doesn't matter. I'm going to pick -3. Let's go here. I got 0, -8. I didn't plot that point. 0, -8, 1, 2, 3, 4, 5, 6, 7, 8, -8. I'm going to plot 1, and I'm also going to plot 4. All right, one of you do 2, one of you do the other 2, or, just double check what's going on. Okay, so leave it as a fraction, decimal, however. So -6. What do I get when I plug in -6? -2 times -8, 16. All right, is it -3.2 or -6? All right, -3.2. Luke Candle, what about -3? You got that?
I got 2.5.
2.5. We got any agreement? Okay, I got a hammer with a little head knot. Like it. How about 1? Luke, you got 1? Or Colton, you got 1?
I said -2.5.
-2.5. Any agreement? All right, thank you. And then how about 4? Colton, you got 4?
3.2.
3.2. All right. Looks like it appears to have some symmetry in terms of that. We'll plug them and get the same. All right, -6, -3.2. 4, 5, 6. All right, you really got to watch where that hits in relationship to that line. Okay, is it above it or below? That's why you have to be careful when you draw that. -3, 2.5 is up there. 1, -2.5. 4, 3.2. All right, what in the world is this going to look like? Okay, with all those points. Vertical asymptote has to go either towards positive infinity or negative infinity. So this piece on the left, here's what it's going to look like. It's got to go through these 3 points. Towards negative infinity is going to flatten out and go along this line. So I'm going to start there, go through this point, and then as it goes through here, it's going to go up there to positive infinity. Over here, now you got this little gap in between -1 and 0. It has to hit 0, -8, and then it's going to go on the other side of the y-axis, up like that. So obviously that's what it's going to look like. Graph it on your calculator. Okay, so let's see. Your calculator looks so much better with the color ones than what I got, but that's all right. X squared plus 2x minus 8 divided by x plus 1. X plus 1. So you get that. Now I'm going to graph that oblique asymptote because I don't think you really have an appreciation for this. How super exciting and super cool it is. So you take a look at that. It's going to go right along there the whole way. Okay, so that's kind of pretty neat. Now, if I'm just going to change my window a little bit. I'm going to go just so you can see -20 to 20. Let's see what's going on there. Scale of 2. Let's go -40 to 40 on the y-axis. I'm kind of guessing here. Hopefully this works out. So there's that. And then you got y equals x plus 1. You can see it goes right along there a little bit in more detail. Okay, but that whole way, it's going to follow that all the way up. Domain? Everything but what? Everything but? -1. So negative infinity. 2, -1, union. -1 to infinity. Range. All real numbers. Okay? All real numbers. Negative infinity to infinity. Okay, so that's how an oblique asymptote looks. Only happens when the degree of the numerator is 1 more than the degree of the denominator. That's the only case. Okay, that's the only case. All right, I'm going to skip this one. I'm going to save that one. So don't cross it out. But there's one more we got to go over first. And you can draw that on the bottom or something. Name that graph. I'm giving you the graph. You're going to give me the equation. So you need to be able to do this. So here's the graph. I'll give you the key points. See if we can use this. So this horizontal asymptote, you should be able to, that's going to be y equals 2. Vertical asymptote, x equals -2. And the key points here, the x-intercept is 3, 0. The y-intercept, 0, -3. Now, there should be arrows on these, but I think we know that, hopefully. All right, see what you come up with. Think through this. What would be the equation? Your homework / class we're going to hand out so that you got that. All right, so you got to have a numerator and denominator. Give me anything you know about it. Okay, anything you can tell me about maybe the equation. Okay, Brooke.
The vertical asymptote is -2.
Is a vertical class with -2. So how does that show up in the equation? Do you know?
When you let x equals 0, no, I don't know.
Remember how we get the vertical asymptotes? Go backwards. So think about your equations. Remember how you determine the vertical asymptotes. Okay, how do we determine it, Ryan?
X plus 2 in the denominator.
All right, so he says that's where the denominator equals 0. So if the denominator, so if I got a vertical asymptote at -2, that means I have an x plus 2 in the denominator. Okay, that makes sense? Okay. What determines the numerator? Okay. X-intercepts. X-intercepts. Good. Good. And that's people tend to forget that one. So I'm gonna put a mental note. So X-intercepts. X-intercepts determine the numerator. And the x-intercept in this case is +3. So what does that mean in the numerator? X minus 3. Okay. Now, as you look at that, I want you to think, why is that not 100% correct at this point? Okay, we're good. We got a good start, but it's not correct. Alex, you know?
There's a swimming for horizontal asymptote.
At where?
2.
2. So you know how that'll affect the equation?
Would they both have to be x?
They don't both have to be x squared, but they both have to be what, Colton?
The one on the top has to be 2 times more than the bottom one.
Okay, and what I want to emphasize is they both have to be the same degree. Now you're right about the x squared. It doesn't matter. It doesn't have to be x squared. It just has to be the same degree. Are they already the same degree? Yeah. Same degree. And so, Colton, what were you saying?
The one on the top has to be doubled out of the bottom one in order for it to be
So what should I put in?
2.
All right, I'm going to put in a 2. Now, here's what you got to watch. So I'm going to put this 2 in here. My question to you is, could I do this? Is that equivalent to what I have up there? And if it isn't, which one's correct? Okay. Can I just put a 2 in front of that x and call it a day? No, because what would that do? That actually would change the x-intercept here. So when you got that constant out in front, you're much better to just go ahead and keep that quantity and just put it in front. You don't need to distribute it. You can, but it's not necessary. All right, does that match everything? The y-intercept really does not affect the graph at all. It is just a checkpoint. So according to this, when I plug in 0, I get -3. Just check it. Plug in 0. Do you get -3? And if you do, you're going to be really confident you got the right answer. Okay. So you got the x-intercept. We got the vertical asymptote. Our horizontal asymptote matches because they got the same degree. And then it should have a coefficient of 2. And when you plug in 0, you do get -3. So we hit all the key points for that one. All right, there's a lot in this. This is one little tiny section. This is section 3.6. I mean, think about what we've done. Graphing, oblique asymptotes, horizontal asymptotes, vertical asymptotes. So there's a lot going on. That's why you got to do this worksheet. We'll go over it tomorrow. The first few there, all you're doing is finding the horizontal asymptote. And I'll tell you, for the first 4, one of them has an oblique. You don't need to find the oblique. You don't need to do the long division for the first 4. Okay, you just need to say no horizontal asymptote. All right, so you got a little bit of time. See what you can get done. Maybe get done with the front of it. Or if you get stuck, I can give you a hand.